This video is on the alcohol functional group and how to name hydrocarbons that have an alcohol on them. So these hydrocarbons contain an OH, which is a hydroxyl group. So the functional group name is a hydroxyl, and then they call these compounds that have the hydroxyl functional group an alcohol. These are names derived from a hydrocarbon name, so they are going to end in OL instead of ane. The OH bond is polar, so that these will end up being held together by hydrogen bonding. And alcohols are more water soluble than just alkanes. So when you are naming alcohols, just like our other names, you first determine the parent chain. The parent chain must be the longest chain, and it has to have that OH group. You number according to the OH group. So that one's always going to be on the end where it's going to have the lowest numbers. It doesn't matter about your other substituents. The OH group, the hydroxyl group, will always determine or be on the lowest numbered carbon. So the format is like before with alkanes and such, where you're going to have your location of your branch, so your number, the name of your branch, location of your OH group, and then your parent chain. And then the E at the end, so the E at the end of like the ane, for example, is switches to OL. Polyalcohols are similar to alcohols. So what that means is that you have more than one hydroxide group. So right before you put the OL at the very end, and it feels kind of weird because you're going to squish this in the middle, is you would put a di-tri prefix. So if you had two of them, you would have something diol. And you'll see that in some of our examples. So let's do a few. All right, so I have to figure out how many carbons in my chain. So in this first one right here, I've got a 3-carbon chain. I've got a hydroxyl group off the second or middle carbon here. And I have 3 total carbons, right? 1, 2, 3. So my name here is going to be 2 from where my alcohol is because I don't have any other substituents. And then I have 3 carbons, so prop. All right, we drop the E from propane because they're all single bonds, and we just write OL, so 2-propanol. All right, this next one, I have a 3-carbon chain. Now I could look this way, I could go this way, it doesn't matter. So if I think of this as my 3-carbon chain, my hydroxyl group is going to be off the middle, so 1, 2, 3. And then right here, I also have a methyl group off of also the 2nd carbon. So first I do my substituent. So I have 2-methyl. And then my alcohol or hydroxyl is located on the 2nd carbon. So 2. And I have 3 carbons total. So propanol. Okay. So now let's talk about this one. So here I have 2 carbons, so I have ethanol, and I have 2 hydroxyl groups. Okay, so they're on carbon 1, carbon 2. It doesn't matter which one you name which, or number, I should say that. But here's where we're going to plug in that di before the ol. So I have 1, 2, eth, because I have 2 carbons. And you leave the name totally the same, ethane. And then we write di for 2 alcohols, ol. All right, so let's do one more polyalcohol like that. So here we have 3 carbons, right? So we've got propanol. We've got 3 different hydroxides, 1 on each carbon. And they're numbered 1, 2, and 3. 1, 2, 2, and 3. So I have 1, 2, 3 for my alcohol groups. I have 3 carbons, so propane with single bonds. And because I have 3 hydroxyls, I'm going to say tri, and then OL for my alcohol, triol. So 1, 2, 3, propane triol. So it's important to remember that you have to name where your alcohol is. The ending, right here, the ending changes to an OL. And any other substituents you do just like you would with any other alkane or alkene or alkyne.